Now, STD, if we have time, I will look at some of the tools there are all based on templates because it increases runtime efficiency very much. So first we will start talking about that, and then we will come back to see what type of polymorphism is provided by templates as compared to polymorphism provided by inheritance. We will look at function overloading and compare that with what is provided by function templates, and we then go to class templates and see some examples. Before, templates, function template, generic programming, these are good places to complete your understanding if you need more information. We don't go into much details. There are bits and pieces we don't look because they are more advanced. Be aware C++ 14 and 17 come, the new version, come with additions to templates part of C++. But we are covering for the moment C11. Maybe we'll just briefly mention some other things coming from C++ 14 and 17. Remember that we look at reusing names. So when we had function overloading, we had a single name which can be used for different algorithms. Add to integers. How to add to integers is different as compared to adding to float values. Remember, integers are no dot point there. They are represented in a specific way in memory. Even more striking, adding two integers compared to plus operator used for strings, where we have concatenation, right? So overloading that plus name has behind different algorithms. One for integers, which is totally different as compared to concatenating strings. It was useful feature, but as you remember, we still have to write a lot of code, repeated code. If we consider absolute function for integers, for float, and for double, we have, okay, reuse the name, but if we look at the body of the function, we see that the body of the function does not depend on the type. It doesn't make any difference that here we have an integer, and here we have a float, and here we have a double. The body is depending on operator comparison, less than 0, and unary operator, minus, it's opposite of an item. So, this kind of situation where we have a repeated code which repeats but does not depend on the type in any way is the situation where we will use a different approach. Instead of writing 3 functions, we can write a single function where the type is a variable. T is a type variable. So we parameterize our function on the type. And now this is what a template is. We can write a single function, we use the same name, and it takes an argument of a type. We don't know what that type is. It can be int, float, double, doesn't matter. But for that type, we have some constraints. That type has to be a numerical type because it has to compare to 0 and has to provide the unary operator minus the opposite. So, if we look at this function, what is important to notice? We put this prefix template to let the compiler know that this is what we call a generic function, where the type is to be decided at the calling point. We will see how this happens. So we have the template keywords, angle brackets, these angular brackets, open and closed, and between them we list what variable we have for types. We can have one, and you will see you can have more than one variables for types. The recent C11 addition is to use type name in front of T. It's very clean. This is it's a placeholder for a type, so type name is good. In the past, class was used instead of type name, and because C++ tries to be accommodating for everything which was before, you will see that it works with type template class T or template type name T. But this is cleaner from my point of view. People using class says I have less letters to type. Old books use still class, so if you see class, they might be old style things. Now, if you look here, the body of the function is the common code we have seen for all our three functions. The difference is T. Now, as soon as you have a template based on a type variable, make sure that that T appears somewhere inside either the parameter list or the return type. Oh, sometimes it will appear here, as we will see in some code. But having template type name T and then integer X, integer A return, it's a big mistake we might encounter, because if you don't have T inside this function, it's not a templated function. So nowadays, these templates are somehow competing with inheritance. Some people think using templates gives us a lot of power, like inheritance gives, but it's even more efficient. Now, combining templates and inheritance can be very difficult to understand in terms of code. Very few types use templates and inheritance. In standard template library we have them, but you will see not too many, because it makes the code very difficult to understand, but it's possible. And we have these templates used in two groups, for functions, as we have seen it before, but most importantly called classes. And for both, be aware, you have to use this syntax: template, type name T, and then some declaration. And this declaration can be the function heading, or we will see the class we try to design with templates. And this T, which can be E or whatever you want, I choose T because it's type, but this is programmer choice. Element type, T, whatever you want, this is a type variable, which is a must when you have templates. Going back to our function, after we define this function, we just can use it in a simple example like here, where you can see we call our function with an int based on the variable declaration, the compiler knows this is an int, therefore I substitute t by int. We don't have to do anything. And because this f was declared to be a float, the compiler substitutes t by a float type. So this t becomes int here, this t becomes float here. And even more, what happens in C++, and in Java is different, the compiler creates the function with int type when it encounters this. So it does the translation for us. It creates the function copying, instead of t int apps blah blah blah, and then performs the evaluation of this function. Then for this creates the function at compilation time, float apps, float this, and then evaluates it. That's why you can imagine there is a lot of code writing by the compiler, and this is one downside of using templates. Code blocking, code blocking. You have a lot of functions defined if you have this type template. Code is created at compilation time, and the object file is very cluttered, code bloating. But for us, we will see it's not such a big deal. We don't worry about this. Now, as you can see, for our function, we don't put any specific condition to let the user know. Be aware, you can use this function if you can compare with 0, make comparison with 0, and if your types allow for opposite values. This is called duck typing. Duck typing means we somehow don't let the user know that there are some expectations in order to use the function properly. So a user which will try to apply this for strings will fail, because this doesn't work for strings, right? Our functions work only for numbers. And this was called duck typing. C++ 14 changes this. When you design a template, you have to specify after template what conditions should the type verify in order to make the code work fine. But we will not look into that because we can't run C++ 14 here. So, as I mentioned before, when we call our function with integer, this function is created for us, written and included in the object file, which we have seen is created by the compiler. These two functions are used for the example. If we try to use it with this type, strings do not compare to 0, notice error. Invalid operands to binary expression. Binary expression was z less than. In instantiation of function templates. So function templates are instantiated, which means the code is written and the types are checked, and we have implicit specialization like in here, and there is a possibility to have explicit specialization. We call absolute with int. We can specify absolute apply to int, and here we have an int variable, but that is explicit and is mostly used for classes. But specialization means what happens when the type is moved to a concrete type. It's not a type variable. integer or whatever. And as you can see, basic string, and this is coming from templates variable. Do not compare to integer 0 in lesser than. They don't, right? It says integer and string cannot be compared. Notice that we have this underscore here. That's at the beginning. There are some facilities in the language which uses underscore at the beginning. That's why I recommend you not to use underscore in your variable names. Underscores, these are two underscore, but there are other places where using underscore at the beginning of variable names clashes with something provided by the C++ system. Right. Now, one specific case. If you declare a templated function and a specialized function, notice they do the same thing. They are called F both. It's not, you can call it overloading if you want, but it's a specific type of overloading. This is a templated function. This is a simple function taking an integer argument. When you use F, the specific type is used first. Like if I have integer as argument, in principle I can use this and this, right? I can have t to be int here, and I can provide a different body, as you can see, a little bit different. Now, the compiler might be confused, but there is a rule in the language which says between a templated and a specific function which matches exactly the type of the argument, the compiler will use the one for the exact match. And that's why for this we get an invocation to this function, as you know, int1. For float values or double values, we get invocation to this. So be aware, there are bits and pieces. And this is one thing we should be aware. We can have different type parameters, right? Like here, T and S. This is a syntax for each type variable. You have to copy type name. And we do a swapping call by reference to provide A substituted by B and B substituted by A. As you can see, the type variable appears here for the local temporary variable, and then we do the swapping. This works as long as the assignment operator is available for these types, right? So be aware, this won't work with numbers and strings, but it will work with integer and floats, or float and doubles, because between numbers you can assign in C++. So be aware again, when we have things like this, we have to make sure that every line of code works inside the function. Yes?
Can we have a temp of S type?
Can we have a?
Temp of S type instead of T.
Temp S instead of T? Yes. Yes, it's a similar, kind of symmetrical. We can have it here S, because we assume that this function will be called only with types which can be assigned. one to another, so it doesn't matter which is there. Right. Because the compiler checks the types, it's better to use this approach instead of macros. So C++ is not happy with macros at all because they avoid type checking and can be a problem. As I said before, most important use of templates is when we declare types, class templates. And this happens for collection of objects of the same type in principle. If you have a list of something, it can be list of integers, list of students, list of accounts, list of employees. A list is a collection of elements of the same type. The operation on lists do not depend on type. On a list, you can add an item to the list, you can remove an item to the list, you can find how many elements are in the list, you can sort elements in the list. But this can be done for integers, for float, for strings, for students if you have a relation operator when a student is less than another in order to be able to sort them. So, class templates are used for classes which can accommodate objects of the same type, and their structures do not depend on the type of elements. We will talk about a simplified array, and we start with an array of integers to see how we can move from array of integers to a template, class template for array. And this is a good starting point. When you will have more experience, you can start writing the templates, class templates straight away. But at the beginning, it's good to start with a concrete class and then move to the general class. This is one approach. So, if we look at this simple array class, array of integer, we will start with having two data members, m size, which is array of int, right? M size, which keeps track of how elements we have in the array, and a pointer to the elements in the array. M data, a pointer to int. And we have here a limited number of method, a constructor, copy constructor, because we are working with pointers. So probably a destructor, but right? We have assignment operator. We have a size method. And we have an index operator to access elements in the array. We don't have a move constructor, which we should, but it will be too big. And for what I want to talk is not important. For your assignment vector, which will be the next assignment, you will have another thing here called capacity, and you will have here move constructor, move assignment, and get capacity and set capacities. But practically, when you will start your following assignment, you can start from these and add things. Anyway, so what we have here for the array, all we do, we initialize the size and allocate enough memory. Right. For copy constructor, set how many elements by copying from this one. It's copy constructor, constant reference. You are probably by now familiar with this. And then allocate memory and do deep copy. This is what happens for this simple thing. And then destructor. A good practice after you delete your pointer, return the memory. Good practice, set it to null pointer, and definitely the size has to be set to 0 because we have no elements there, and some functionality rely on the size of the object. Sometimes you want to see if the array is empty, then you check that the size is 0. It means the array is empty. Anyway, this is the assignment operator. Check against assigning to self. If this is not the case, we'll do the whole thing with allocating memory and return the current object. Size, which returns m size, it's a constant, is an accessor method, as you can see. And then the index operator, which can appear in both sides, right and left. That's why we have this. Return by reference that we can assign to our object, location to whatever. And return the element at index. As you can see, we don't perform any checking that the index is between 0 and size -1, which would be good if we really look for safe data. Normally here we should return this only if the index is between 0 and size -1. But for what we are talking about, this is once again not important. After we have this complete type, how are we going to make an array of any type? What things have to be changed where we have a type variable? So this array is a candidate for templates because, once again, if we look at all this data, there is nowhere an operation which depends on int for data related to the type of objects. Okay, when I talk about this is this int, because int appears in two places. Int appears for the size. This will stay int, whatever type of array we have. Whether we have an array of float, of strings, of students, this will stay int because it refers to number of elements, right? But this int, which refers to elements in the array type, this int does not influence any of the code here. Any of the code which appears here is not dependent on the properties of int type. For example, for the constructor, if I put this to be a generic type, integer size should be integer. Here, instead of elements of int in my array, I can put very simple elements of t, generic type, or e, elements of e type if I want. So, this is the meaning of array is a perfect candidate for templates because the type of elements in the array does not influence the method of the type. So you should make a distinction between functions and classes. In general, classes which are class templates do not have restrictions as opposed to function templates. Function templates, sometimes in their body, they use some operations which restrict the use of the function. But for classes in general, you don't have. Class templates are the really general type. If you want an array of floats, you have to write the same code with floats everywhere instead of int. If you want an array of strings, you might need to rewrite code with string, but a lot of code is copied and it's a waste of programmers' time. So we can write a template class based on our array, and notice where the changes are. Very few places. First of all, you have to put the prefix, template, type name, whatever you want to call it. And then you write the name of the class. And then, notice here, we have no problem. For copy constructor, be aware, you have to specify this is an object of array T. Remember, A is an object of this type. But this type is now array T, it's not simple array. This is the name of the class, you don't need T there. And then, assignment operator again gets an object of reference, constant reference to an object of Z type. This is unchanged. This, because we are referring to the object in the array, it used to be int because we have integer elements in the array. Here we have T. And then this is a pointer to a T-type set. So when you move to writing a template class, you have to decide which stays the same, which changes, first thing. And then go through the code we have seen, and this is something you have to become very familiar with. You write the functions outside the class, not in line. This is a requirement for 234. You can write them inside the class, but my request will be for your assignment, for your exam, you will have a question about this, because templates is big part of what we talked about after the exam, after the term test. So you will have to make sure that you are familiar. Template, type name, T, because these are function templates. They are method of your class. The class being a template, these are function templates. And then we start with a constructor. This is the name of the constructor, and it's of this type. So T appears. Be aware. This is referring to the number of elements, stays the same, allocating data for this generic type elements. Then we have the copy constructor. Copy constructor, another function template, is the same type. All are of this array T type. And the only change inside the function is what type of elements you allocate. T-type elements. For the destructor, as you can see, nothing happens. Nothing to change except the heading. You can write like this, the prefix here, or you can write in one line. Sometimes it becomes very long, the lines. That's why people used to put it on 2 lines. It's okay. The assignment operator. Okay, so it returns a reference to an array object type. It's the operator of this type and copies this object of the same type, right? So you have to identify each thing. And inside the assignment operator, the only thing, new T. Everything else is like before. Returning the number of elements, and the last is index operator. As you can see, nothing changes here, just the return value has to be T and everything else works. Now with that kind of conversion, we can construct array of integers, array of float, array of students, array of whatever type you have defined. Array of what you had for your assignment 2 part 1, employees. You can have array of any type you want here, like a collection. And in this example, we have an array of integers with 10 elements and an array of floats with 100 elements. We set some values and then we display them just to see how it works. Now, you can define not only simple array, you can define references to array types, pointers to this type, like you define pointer to integers or pointer to float. Your type has the same power as the native types. So C++ allows for extendability much more than C, as you can see. And things can become very complicated because we can construct an array of int. So each element is an array. Sometimes this was considered two-dimensional arrays, right? Or something like this 3-dip nesting. Very seldom things are used in this way, but it's possible. And this is an example of the fact that data type in C++ is recursive. Array of array, array of array of array. This is recursion. And it works not only for functions, but for types as well. Now, compiling types is unfortunately moving away from modularization. Templates must be defined with the only source CPP files that uses them. In other words, you have to put everything in the same file. Everything in the same file because, as you have seen, the compiler creates the function before it uses. So it needs access to the body to the body of the function. And because it needs access to the body of the function, that has to be known to the compiler before execution. Therefore, one approach is to put everything in one file, or put the class for templates, the class declaration and the class implementation in the same file called myclass.h, and then when you use it in another file where you have the main function, include the z file in main. But the main point is that modularization we have seen on C++ with header file, implementation file is fortunately not sorted out at the moment in C++. The source code for the template must be available to the compiler whenever the template is used. And if you don't use the template, the compiler doesn't check the syntax. So be aware when you define templates, you have to call it. effectively. Otherwise, you might have a wrong templated function. If you haven't called it, the compiler does not check the syntax and correctness. I mentioned this type name or class. The C++ max function in the standard template library is defined like this, with type name, but it's the same as this. This was the approach, as I said before, C++ 11. This is the name the programmer uses, the name which is appearing here. Right. So, function and class templates provide polymorphism, but different type is provided by the inheritance. I said at the beginning, and different approach as compared to overloading. In the overloading, I said we have a name, and behind that name, we can have different algorithms. Whereas templates, function templates, you have the same algorithm, and you obtain behavior for different types. Absolute is one function for template, but you can use it for int, for float, for strings. So you have a single algorithm here. And this type of polymorphism is called parametrized polymorphism. Parametrized polymorphism, as opposed to polymorphism provided by inheritance, which is called subtyping polymorphism. Subtyping polymorphism is provided by inheritance because the derived classes can be used via base class subtypes to provide different behavior. With templates, you have, as I said, single algorithm, but different parameter types used to obtain the behavior. Okay, and next we will look at this code, and we have 10 minutes to do a quiz. Okay. So, I have provided a short multiple choice quiz because I think you have multiple choice in your exam. So, can you please try to solve these exercises? 5 minutes, there are 5 multiple choice questions. Okay, so can you pass them around, please? Can you pass them around? Are you in 234? Right. I can give you a quiz. Everyone, you start solving them. Thank you. Yes, I have them. Yes. Let's see what you have remembered from what we talked about. Good. We have a result, right? So, for the first question, the answer is A, exactly. For the second question, why we can't use this swapping for array? What is the answer? A, B, C, or D? Why? Someone?
I would say.
Exactly. You can't assign arrays. And as you can see inside the swap, we need assignment. So C is the correct answer. Very good. 3. Which of the following are not valid calls to larger? What is the answer? D. Again, because inside larger, you have to compare two arrays. You can't. So D is the correct answer. And 4, when would you want to make a function template? A, B, C, or D? A. Well, data does not matter. Data type. That's why we have the type as a variable, because it doesn't matter that it's int or float. So A is the correct answer. And 5, if you define some list class template and then declare a list of integers, 2 lists of doubles, and 1 list of strings, how many different versions of the template class will the compiler provide? 1 for integers, 1 for doubles. Integers and doubles are considered different groups. When templates are involved, in very few cases, it can be converted, but when classes are involved, integer is one type, doubles is other types, and string is another type. So there are 3 types. So this is the correct answer, 3. And now I put this on your screen. The example is the array template, and I run it with cite2. First of all, I get this warning, which somehow makes sense, because what we have here, we have this size, and then we have this size, and the compiler complains, right? But now let's see, with C11, C share, where is C share? Okay. If you run it on C shell, this is there the compiler can sort it out. One simple solution is get size here, and this will solve the problem. So instead of size, everywhere we can, or probably simpler to say size 1, whatever, and change that name, size 1 here, and size 1 here, to make the compiler happy here. And I hope that is the only thing. 552.3, and I think we are now happy. Another thing which is not quite right here, if I put this A4, okay, I will sort it out. A4, and I run. A4, I haven't defined it, but arrays in general. Okay, now I think that I put too many. Yes, as you can see, 0, is even if I haven't assigned anything to A4, because arrays get default values in general. If you run the same program in a CPP shell, it doesn't complain about size, which says that in the newest, it depends on the compiler a little bit. When templates are implemented, so be aware that templates are somehow handled differently by different compiler. You might get a slightly different output with C++ compiler in Xcode as compared to C++ Sci-T and template, because there are a lot of changes in them. Compilers are a little bit behind of dealing with the templates in a standardized way. But this means that when you solve your assignment 2 part 2, you check it in the lab. Make sure that it runs in the lab. Thank you very much. This is the end. And we can talk, if you have questions about assignment or whatever, outside. So if there is a lecture, they can come in. Thank you. See you on Wednesday.